Hey everyone, welcome back to a new video, and in this video we're going to discuss one of the most important thing that you should know if you are an Android developer, and that is solid principle. So solid principle is most important thing if you want to make your application more scalable, maintainable, testable and robust. So without wasting any time, let's get started and see how we can use solid principles to make our application more robust. First thing first, go to your description box where you can find my initial project GitHub repository link. Download the project and open up into your Android studio. So we have few modules in this initial project. We have authentication module, billing module, camera module, common, notification, rest. So I'm gonna use all of this module to explain you all of the principle. By the way, solid is an acronym of 5 different principles. S stand for single responsibility principle, open close principle, Liskov substitution, interface segregation and dependency inversion principle. So we are going to deep dive into this principle. So first principle says your code has only one reason to change, or it has only one responsibility. So let's discuss this thing with code, how we can understand that our module or classes will have only one responsibility. So for that, you can see over here we have a REST module. This REST module is actually used to communicate to the backend. Now it has only one responsibility. So if you are seeing this on the module level, it has only one responsibility. So it deals with the backend communication. Now when I open up this module, we have here one interface naming network communication, and corresponding to that we have implementation. Now what will happen if you want to add one more REST API call in this module? Yes, you can do that thing very easily because you are adding a REST API call. A REST API call will somehow relate to the REST module. Due to that reason, because our module has only one responsibility and only one reason for change, which is related to the network communication. Now if you want to add any REST API call, eventually it will perform a network communication. Due to that reason, you can add that function in here and it is properly valid. It won't violate single responsibility principle. Go to your network communication interface and here add one function, get info. Okay, simply go to your network communication implementation, press Ctrl I, enter, override get info function. Now this won't violate single responsibility principle because right now we are only and only dealing with a REST API call, and this is the sole purpose of our REST module. So it won't break or violate single responsibility principle. Now I'm going to show you an example how you can violate those principles and fix it. So for that we have here billing module. So let's say your application is a billing module that will generate bills to your client, and ultimately you will generate a report of the bills that you have been given to the clients and send this report to your godfather or the business owner of your application or your business. So for that we have this billing module. Now the sole purpose of this billing module is generate bills for the client. But when you open this thing up, we have one class naming billing manager. Now the purpose of this billing manager is create bill, extract report so that we can share this report to our business owner, remove the billing item, pay the bill has been paid. Billing manager responsibility is to create bills and also extract the report. Now extracting report is something which is not related to the billing manager, not related to the billing. So this will break the single responsibility principle or violate the single responsibility principle. Because if you want to generate a report, so for that you have to create a different module. The sole purpose of that module is to generate report. But here I'm using extract report functionality in our billing manager class. This is totally wrong. You have to create a different module naming report, and in that report all of the things which is related to the report generation will be present on that module. So let's do that. Let's remove this responsibility from our billing manager so that it won't violate single responsibility principle. So for that, go to the file, new module, Android library, and here I'm gonna generate one module naming report. So here we have our module. The sole purpose of this module is to deal with the report related stuffs. Okay, so go in the Kotlin plus Java, and here in this report I'm gonna create a class, and the class name is report manager. Now in this class you can simply cut this function out from your billing manager and paste in your report manager. Okay, so this report model class is present in our billing module. So simply remove this report, but before that let me make a package, and the package name is model. Simply drag and drop this thing over here. Now go to back report manager and simply import. Okay, so now you have properly validating our single responsibility principle, because now we have report module and the sole purpose of this report module is to generate report or do something which is related to the report. And in this class report manager, we are using a functionality of extracting the report. Now this won't violate your single responsibility principle. So what do you mean by single responsibility principle? Your code has only one and only one reason for change. This is our first principle, which is single responsibility principle. Now let's jump out to the second principle, which is open closed principle. And the statement of this thing is a piece of code is open for extension but closed for modification. This is the statement. I know you are not getting it by just listening this statement, but still I'm gonna explain you this statement with a very simple example. So let me close everything. So for that we have one module, and the module name is notification. Okay, so feature wise, this notification is actually used to notify our modules regarding the notification that we will receive from the FCM or any other service. So simply open this thing up. We have here a class, and the class name is notification notifier. So it won't violate our single responsibility principle, because the sole purpose of this notifier is to notify our module regarding the notification. And we have one class which is related to the notification, naming notifier, and this will eventually use to notify our modules. Okay, now go back to your notification notifier. We have a function named send, and in this send function, by using this module identifier, we will identify our modules. So if the module identifier type is billing module, we want to send a notification. If it is a case of user module, we will send notification. Now what will happen if we have to add one more module? In that case, you have to come in here and make the changes regarding that module, so that that module will also listen this notification. Now this function or this class is totally open for modification, because when you add any other module, you have to come in here and add that module branch in this when expression. This is wrong, because your class is open for modification, but our second principle says that classes or any piece of code is open for extension but closed for modification. But now in here we are opening our class for modification. This is entirely wrong. So let's see how we can fix it so that it follows this second principle, which is piece of code is open for extension but closed for modification. So to do that, on the top, and also our notification notifier will know about other modules. This is also a bad practice. This notification notifier will never know about the other stuff which is not in their scope. So let's see how we can fix it. To do that, I'm going to create an interface, and the interface name is notificable. And in this, I'm going to create a function. So first function name is should notify, and the return type of this thing is boolean. Next, we have one more function which actually used to notify. We have to pass our message and the module identifier. By the way, this module identifier is present in our common module. I know you are thinking that this common module will eventually break the single responsibility principle, because in common module we will put all of our constant, all of our shared things, shared resources. So it will clearly violating the single responsibility principle. But at somewhere you have to create this module, because if you are not using the common module, eventually your application size will increase if you are using the same resources in different module again and again. So yeah, I know it's violating the principle, but still you have to define the responsibility for this common module. To do that, you can use here packages. Like let's say you want to put constant in here. So for that you can create a package. And in this package, now this package has a responsibility which is totally related to the constant. You can put that constant, you can provide some logic to your constant in this package. So this package has a clear one responsibility, but your common module doesn't have one responsibility, it has many responsibility. So at some point you have to do this thing. I know it's breaking the principle, but still you have to do it. So jump to our second principle, which is open close principle. Alright, so now it's time to use this interface. Now in this constructor, I'm gonna pass a list. Type of this thing is a list of notificable. Remove this thing from here. Use your list. Grab the first If you are getting the first, what you can do, you can simply use it and check whether you are able to notify this module or not. If it returns you true, then you can notify it by passing the message and the module name. So now by doing this thing, we can actually remove this notifier. Now your class is closed for modification but open for extension. So let's understand this thing with very simple scenario. Let's say you have one more module that you will create in future. So in order to notify that module, you don't need to mention that module information in here. Due to that reason, you don't need to make any change in your notification notifier because it is now handled by this. And this notifiable interface will be implemented in your module, and you can define the logic corresponding to that module. So by using this, you can actually make your classes or a piece of code is open for extension but closed for modification. What do you mean by open for extension? So to show you, first I'm gonna make this class open, and also my function is open. And in the bottom, I'm gonna create a class which is actually used for special notifications. Okay, now in this you can use your notification notifier, and the requirement of notification notifier is a list of notificable. So simply copy this stuff, and in this class you can use it and pass it over here. Cool. Now you can simply override the send function, and here you can define your logic. Now this is open for extension but closed for modification, because as I told you, now if you are adding any module, so to notify that module, you don't need to change anything in this notification notifier. This is what open close principle is. Piece of code is open for extension but closed for modification. Next, we are going to discuss Liskov substitution principle, the most complex principle of this solid acronym. So what is Liskov substitution principle? The Liskov substitution principle tells you that you need to be able to exchange objects from the same family without breaking your application. If you are creating a system of interchangeable parts, then those parts must agree to a contract that allows them to be substituted for another. I know you are not getting anything, so let's jump into the code and see what are those statements was saying. So in order to tell you about Liskov substitution, I'm gonna have here one module naming authentication module. So first, just verify whether it properly following the single responsibility principle or not. This module is have only one responsibility, and that responsibility is authentication. So if anything is related to the authentication, then you can jump in here and make those changes. It will perfectly fine. It won't violate the single responsibility principle. Now it's time to open this thing up. We have here authenticator. So this authenticator is an interface. By the way, contract means an interface, an abstract class, or any template. So you can use that thing as a contract to those parts. So we have here authenticator, email authenticator, then fingerprint authenticator, and Google authenticator. That means we have one family naming authenticator family, and that family has a few different implementation like email, fingerprint, and Google authenticator. As you can see, this interface contains two different functions, login and logout. So in this login, we have two different parameters, username and password. In our email authenticator, we do require username and password. In our Google authenticator, yes, we do require username and password. But in our fingerprint authenticator, we don't require username and password because fingerprint doesn't contain username and password. So it's a very wrong way to send username and password to fingerprint authenticator. Well, if you are using authenticator family in, let's say, in your app module, so instead of telling you, I'm gonna use that. So let's say in here I'm gonna create authenticator. So for that I'm using my fingerprint authenticator. Well, this app module doesn't know about authentication module. So to do that, go to your Google Scripts app module and here add the project. So I'm using here auth sync your project, and now we are good to go. Go to your main activity and here use fingerprint authenticator. Cool. So if I'm using here authenticator.login and pass my username and my password, eventually it will break your application. As I told you in the statement, you need to be able to exchange objects from the same family without breaking your application. But here, if you are using fingerprint authenticator, it will eventually break or crash your application. this won't follow our Liskov substitution principle. So let's see how we can fix it. Although it belongs to the same family, authenticator family, but it will break your application. So let's see how we can fix it. So to fix it, in this authentication, I'm going to create a package, and the package name is credentials. That contains a sealed class, and this sealed class name is credentials. This is a sealed class, so use your sealed keyword, and in this we have data class naming user credentials. Pass your username and your password, so wall password. Type of this thing is string, and extend this thing with credential. And we have one more thing which is totally related to the fingerprint credentials. So if you are having any credential, you can create a data class, but I don't have any, so I'm using here data object, and extend this thing with credentials. Now go to your authenticator. Instead of using this username and password, you can use here credential and change the implementation. So instead of using this, you can use credential. Now in this you can check if our credential is of type user credential, then only you can proceed. Similarly, copy this stuff, come back to your Google Authenticator, change the parameter and use it in here. Similarly, go to your fingerprint authenticator and change this parameter. Now you can check if our credential is of type of credentials dot fingerprint credential, then you can proceed, otherwise you won't. So by using this approach, now you are able to replace the authenticator with fingerprint authenticator, and it won't break your application. So this won't violate the Liskov substitution principle, as it says that you need to be able to exchange objects of the same family without breaking your application. So now you can replace your authenticator with fingerprint authenticator, with email authenticator, with Google Authenticator, and it won't break your application. So this is a way using which you can follow the Liskov substitution principle, and I hope you got it. What is the Liskov substitution and how we can use Liskov substitution to make our code more robust, more decoupled. So now we are going to discuss the next principle, which is I of our solid acronym, and the full form of I is interface segregation principle. It says that instead of creating a bulky interface, you should create small interfaces that make more sense, and also it will increase the reusability of those interfaces. So to show you the problem and the solution, I'm having a camera module. So this camera module is actually used to capture the photo and videos. Now in this we have an interface naming camera feature that has few functions in it. We have two different classes. So first is photo camera. So the responsibility of photo camera is to capture photos, but because of that interface we are forced to implement all the other member functions. Similarly, for the video camera, responsibility of video camera is to capture video, but still we have to implement those other functions because of my interface. So let's modify our camera feature interface. To do that, I'm using here an interface, and the interface name is video capture. This interface contains my capture video function. Similarly, for the photo, I'm using here one more interface, and the interface name is photo capture. Pass the capture photo function in here. Okay, so in order to control our flash, I'm going to create one more interface, and the interface name is flash control. Cut out these functions and paste in here. Remove this camera feature. Okay, so now go back to your photo camera. So this photo camera is only interested to capture photos. So instead of using all the things, you can simply use photo capture interface and remove all the other steps. And also we want to control our flash. So to do that, you can pass your flash control interface in here and use that flash control in our capture photo logic. Okay, now the same thing I'm gonna do with this video camera. Remove this camera feature and use your video capture. Remove this function too, and in its constructor you can pass your flash control. Okay, so now our interface is segregated. We have a small interface that make more sense, and also reusability wise it is more reusable compared to the previous one. Now let's see whether all the principle that we have just discussed in this video is properly followed by our classes or not. So go to your photo camera, and in this photo camera we have only one responsibility, which is capturing the photo. So this is fine. Next we have video camera. So this video camera has one responsibility to capture videos, and yes, it has been properly following all of my principle that we have discussed yet. Single responsibility principle is properly followed. Now next we have open close principle. Classes are open for extension but closed for modification. So yeah, these are the closed for modification, because if you change anything in your project it won't affect this logic. So yeah, this is closed for modification. Now what will happen if I want to make one more class to capture high resolution video? So to do that, I'm using my video camera. So the requirement of video camera is flash control. So simply pass that flash control in my high resolution video constructor and pass it in here. If you want to make your class open for extension, you should use here open keyword, and now you can use the capture video. Video camera is open for extension but closed for modification. So this also follows the second principle, which is OCP. Next we have Liskov substitution. So Liskov substitution principle says that you need to be able to exchange objects from the same family without breaking the application. So yeah, go to your camera feature, and if anything belongs to this video capture family, you can replace it very easily. Yes, it follows the Liskov substitution principle, because in video camera we have two different classes, video camera and high resolution video. So if you want to replace your video capture family, you can do it very easily and it won't break your application. So yes, it follows the Liskov substitution principle too. And interface segregation, yes, it follows, because we are just learning that thing through this feature. So yeah, all the four principles are properly followed, and also it follows the dependency inversion principle, which we will discuss next. So now we are going to discuss the last acronym of our solid principle, which is D, dependency inversion principle. It says that high level module should not depend on the low level module directly. Instead of this, it depends on abstraction. So let's understand this thing with an example. I'm in my app module, and in this I'm gonna create a class, and the class name is authentication view model. This is a class, and this class will depend on authenticator. Okay, so now we have here a function to perform login, and the requirement of this thing is credential. Use your authenticator and perform a login, pass your credential. Similarly, I'm going to perform logout operation using our authenticator logout. So authentication view model will depend on authenticator. Now auth view model will act as a high level module, and authenticator will act as a low level module. Cool. So in this authentication view model, high level module should not directly depend on low level module. Instead, it depends on abstraction. So how it will depend directly to our low level module? So to do that, you can simply use your email authenticator. Now our authentication view model or high level module will directly depend on low level module, which is email authenticator. It does not depend on abstraction. But if I remove this thing to authenticator, now our authentication view model will depend on abstraction instead of directly depend on some third party class. So this is what dependency inversion principle says. Your high level module will not directly depend on the low level module. Instead, it depends on abstraction. So that principle will be properly satisfied by our view model, because it does not directly depend on any other implementation of the authenticator. So let's see how we can use it. So go to your main activity, and at the bottom, I'm gonna create a function main. And in this, first I'm gonna use here Google authentication. So for that, we will create our Google view model with the help of auth view model, and we will pass here our Google Authenticator. So use Google Authenticator, create an object of Google Authenticator and simply pass in here. So by using the abstraction, your authentication view model is loosely coupled and also it is testable. You can create a lot of scenarios and do the unit testing or UI testing. We are done with our Google authentication. Now it's time to perform the user authentication using email. Okay, so for that, create here a variable naming email authenticator, generate an object of email authenticator, use your view model, which is authentication view model, because I'm using your email. So let's call that thing email view model. Create authentication view model and pass your email authenticator, so it will do the authentication with email. Now next we are having your fingerprint authentication. Use fingerprint authenticator, create an object of it. Lastly, create an variable naming finger view model authentication view model and pass your fingerprint authenticator. Alright, so by using this approach, you can now use your finger view model with 3 different things, because your view model will not directly depend on the implementation of authenticator, whereas it depends on authenticator, which is an interface and abstract thing. Due to that reason, now you can use your authentication view model with the authenticator family very easily. You can replace it in testing and also it is very loosely coupled. So this is what dependency inversion principle is. Alright, so that's it for this video. I hope you like this video. It's a very cool video for those who are very serious programmer who believe the solid principle will eventually use to make their application more scalable, more robust, more testable and more maintainable. We will meet in our next video where we'll discuss something new about Android, and if you are having any suggestion, any doubts, you can write those things in the comment box. We will meet in our next video where we will discuss something new about Android. Till that, goodbye.